This is the second page of our SAT practice test. Number 5 says, which of the following is equivalent to the expression above? So all this is exactly what we learned in our first chapter this year, which was functions, and this is subtracting functions. So the only difference is they have a little bit higher of a degree because they have x's and y's. Some of them are squared. So first we want to distribute the negative, just like we did when we learned about this. And you get x squared y minus 3y squared plus 5xy squared plus negative times a negative is plus x squared y minus 3xy squared plus 3y squared. Okay, so we're not looking at that. All of our signs should have changed. Okay, and we're looking for like terms. So x squared y should make 2x squared y, which I see right here, 3y squared, and negative 3y squared should cancel. So I shouldn't have any y squareds, which I do here, which is making me think this isn't the answer. And then 5xy squared, negative 3xy squared, definitely choice C. Okay, so pretty simple, not really any tricks there. Definitely using what we learned in school. Number 6, the first time I saw this problem was a little bit confused for some reason, but it's actually pretty simple. It says a pediatrician used the model above to estimate the height h, so this is height of a boy in inches, in terms of the boy's age, A, in years, between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? So the first time I saw this, the 2 to 5, ages 2 and 5, confused me so much because I was trying to plug in 2 and 5 and then find the slope between those 2 points, and I don't know, I was just confused. But if you read this, it says, what is the estimated increase, right? So keyword is increase, in inches of a boy's height each year. Okay, so every year says that that's going to be a variable, and age or year is going to be the variable. So what does it increase by every year? 3. So that was one where it doesn't require math. What this is y equals mx plus b again, but looking very different. So we did see one that looks similar in the beginning of this on the last page, where it's in mx plus b, but it's hidden because they use different variables, but really it's the same thing. It's asking you about slope and y-intercept and then making it more confusing for some reason. So the fact that it increases and it's per year, 3 is our answer. So pretty simple. And then you can talk about the fact that 28.6 is the starting height. So maybe the average kid at 2 years old is 28.6 inches, and then they grow at a rate of 3 inches per year until they're 5. And then they probably have a different equation that models a different age, because you might not grow as much from ages like 6 to 8 as you grow from ages 2 to 5. All right, number 7. Number 7 is a great problem. So it looks obviously very confusing, right? It doesn't look simple whatsoever. It's actually one of the craziest equations I've ever seen, but the operation is actually very, very easy, and there's no math required here, which is crazy. So it says the formula above gives the monthly payment M needed to pay off a loan of P dollars at R% annual interest over N months. Well, that's interesting, but that's a lot of information. Which of the following gives P in terms of M, R, and N? So my observation is that the original equation is M equals, and all of my answers are P equals. So what this is a literal equation. And literal equations are equations where we're solving for a variable. So sometimes I'll give you like area equals pi r squared and say isolate r. So you would divide by pi, and you get r squared equals a over pi, and take the square root. So we get r equals. That's what a literal equation is. And why we know that in number 7 is because it goes from being m equals to p equals. So they did something to the equation to make it p equals, okay? So from the original, we're looking at the fact that it's some fraction multiplied by p, okay? And normally if we have a coefficient of p, we would divide by that coefficient to make it go away. But the way that we divide fractions is to multiply by the reciprocal. So if you multiplied by the reciprocal of this on this side, which is a bunch of craziness, like really irrelevant, but we're multiplying by the reciprocal. You could literally just scribble scrabbles in here. It doesn't even matter. Multiply by the reciprocal. If it's on the bottom, there should be a 1 there. And on the top, it cancels. And if it's on the bottom here, on the top here, it cancels. And if we do that to one side, we have to do it to the other. So literally, the answer that you're looking for is just the flipped version of this problem. And that's it. Which is crazy that it could be that simple. And then r over 1200, 1 plus r over 1200 to the n, okay? None of this work is really necessary as long as you understand the concept that all you're doing is multiplying by the reciprocal. So it's choice B. Look at the original. To cancel a fraction from being multiplied by p, we multiply by the reciprocal on both sides. That's it. So that statement, that piece of knowledge is what you need. Other than that, no math required. So looks confusing, sounds confusing. It takes one piece of knowledge and you don't even need to use math. Okay, let's also do page 2 on here. So it says, if A over B, there's an announcement. Continuing. If A over B equals 2, what is the value of 4B over A? Okay, this problem's getting a little bit more complicated, but what I notice is that here I have A over B, right? But I want to know what something is that has a B over A. So at some point when I'm playing with this equation, I'm just going to play around with it. It's kind of what you got to do on the SAT. I have to play around with it so that I can get B over A. And then maybe I can find out what 4B over A would be equal to. So what I'm going to do is, the only thing I really can do in this equation is multiply by B to cancel out the fraction. That's really the only move I can make. It's kind of like checkers or chess where you have to make a move, but you know what? There's really only one move you can make. Now, if I did want to get A or B over A, just like I see here, I'm going to divide by A here. And I get A over A is equal to 1 equals 2B over A. Well, if this is 2B over A and this is 4B over A, what did we multiply this guy by to get to 4B over A? We must have multiplied it by 2. And if we multiply the left side by 2, we'd have to multiply the right side by 2. So we'll get 2 equals 4B over A. So what is 4B over A equal to? 2. Great problem. It's a really good SAT example. It looks like a lot of problems that I've seen for SAT before, where no time in school did we teach you how to do anything like this, because it's not a specific type of problem. It's just using a bunch of skills that you know, how to manipulate equations, substituting, that you can use the multiplication property of equality here, a few things that you've learned in school, bringing it into like a random math problem. All right, number 9, I'm sure you've seen before because this is just a system of equations. So you guys totally know how to do systems of equations because we just went over them. This is what is the solution xy to the system of equations below. So first of all, we want this to be in standard form, or at least close to standard form. Standard form technically says that the first term has to be positive. I'm not worried about that. What I am worried about is that my x's and my y's line up. So I'm going to multiply this bottom equation by 3. so that I can eliminate x. So you get 3x plus 4y equals negative 23. Negative 3x plus 6y equals 57, negative 57. Okay, our x's cancel out, and we're left with 10y equals 70, 80, negative 80. So y is negative 8. Okay, not negative 8, not negative 8, not negative 8. Don't even have to solve for x. Okay, number 10. For the function g defined above, a is a constant, and g of 4 equals 8. Okay, when we learned about functions, I specifically remember saying that the statement g of 4 equals 8 is so important for you to understand. What this says is when I plug in 4 for x, right, because that's what it says, that's x and now it's 4, I get in the end 8. So what we can do is take that statement and plug it into here. G of 4 equals a times 4 squared plus 24. But I also know what g of 4 is. What is it? 8. Okay, now the only variable that I have left is a. So we get 8 equals 16a plus 24. We're going to subtract 24 on both sides. And you get, sorry, I got distracted. Negative 16 equals 16a. Therefore, a is negative 1. So when you go back to this problem, you're going to take this, and now you have a normal looking function. G of x equals negative x squared plus 24. Now you can find out any number when you plug it in for x. So I'm going to plug in negative 4 now. So negative 4 squared plus 24, which is totally what we talk about all the time, the big mistake everybody makes. So we get negative 16 plus 24, which is 8. Okay, great problem because it is quadratic, so it's a little bit of quadratic knowledge. It's functions, it's substituting values. Again, SAT is always trying to test more than one topic in each question because there's only so many questions on the test, but so many things that you learn about in school. All right, number 11. In the equation above, B and C represent the price per pound in dollars. So B would be dollars and C would be dollars of beef and chicken. So money spent paid on beef and money spent on chicken, respectively. Meaning beef comes first, chicken comes second. X weeks, so X stands for weeks, after July 1st, during last summer. Okay, so now what was the price per pound? So price per pound, is that X or is it B or C? It's B and C because that is the money per pound. When it was equal to the price per pound of chicken. Okay? So what they're saying is price per pound of beef is equal to price per pound of chicken. Or when were they equal? Okay, when meaning time, which means solve for X. So what they're telling us is that price per pound of beef, aka B, and price per pound of chicken, aka C, when does B equal C? Well, I know that B is 2.35 plus 0.25x equal to 1.75 plus 0.40x, which is B being equal to C. When? What was the price per pound when these two were equal? So I'm going to find out when they were equal, and then they actually want to know the price in the end. So they don't want to know X, they want to know B and C, but we have to solve for X first to find that out. So I'm going to get all of my variables to one side, maybe subtract 1.75 from both sides. So we should get 0.6 and then subtract 0.5x.